Everybody, thank you, Brittany, for that bang-up job of introducing me. So welcome, everybody, to this webinar on OSPF LSAs. Glad you were able to attend. So I don't have any PowerPoint slides or anything today. It's just going to be you and I, close friends, talking about link state advertisements, something that everybody talks about at Starbucks these days. So this is a topology diagram I've worked up here. I've got a lab in the background I'm going to share with you. And we're going to watch these little LSAs floating around and doing their thing and becoming of major utmost importance. So let's start sort of at ground level here. I'm assuming that you already know that OSPF stands for the Open Shortest Path First. It's an IPv4 and IPv6 routing protocol. And one of the things that makes OSPF kind of unique in the world of routing protocols is that some routing protocols, you know, here's my favorite phrase, I'm a router, you're a router, okay? In some routing protocols, if you and I were routers and we're directly connected, and I knew of a bunch of routes behind me, I would send all those routes to you. I'd say, hey, here's the 20 network, here's the 50 network, and the next hop would be me. So as far as what you knew, you would know there were routes behind me, but you wouldn't know what that topology looked like. As far as the topology, it'd be you, me, and sort of like a big cloud back there of a whole bunch of networks that I've told you about. OSPF doesn't do that. The designers of OSPF said, hey, a router should learn about everything. It should learn what the whole topology looks like, and not only who its neighbors are, but who their neighbors are behind them, and their neighbors behind them, and what the links look like. And it should be able to basically put together this big jigsaw puzzle map of the topology. And then once it puts that together, it should have the intelligence itself to figure out what the shortest path first is to get to any particular destination. Now, how's it put that map together? Via LSAs. So the link state advertisements are like the individual jigsaw puzzle pieces that a router collects, fits together, and that's how it knows what the topology looks like. And that's what we're going to talk about today are what are the different kinds of LSAs, what types of routers create them, what's their purpose, what scenarios will you see them, what scenarios will you not see them. So let's just jump right into it. Okay, so you probably, if you've spent any time studying OSPF, even like 20 minutes, probably the first thing you learned was that in OSPF we have this concept of areas. So if I'm a router and I've got a link here and I've got a link here, part of configuring OSPF is I have to tell the router what area these links are in. Now, if you wanted to, you could have every single router and every single link in one giant area. Now, a lot of people think, oh, if I've just got one area and everything's in it, that should be area 0. Well, it's from a design perspective, it's probably a good idea to make that area 0, but you don't have to. You could have all your routers in area 22 or area 17. The number is irrelevant. The main thing that's important is that if you're a router and I'm a router and we're directly connected and we want to become OSPF neighbors, we have to agree that this link is in an area. In other words, I can't think it's an area 0 and you think it's an area 21. That won't work. If that's the case, we won't become neighbors. So as long as we agree that this link is in some common area, we're good. Doesn't matter if it's area 0 or area 37. Doesn't matter. So that's probably the first thing you learned about OSPF is this concept of areas. Now, like I said, when a router has at least one link in an area, for example, let's look at our picture right here. Let's look at area 51, okay? So let's look at router 2 right here. So I've already pre-configured this router, and I'll show you what that looks like, so that he knows that gig 01, gig 04, and gig 00, all three of those links are running OSPF, and they're in area 51. So he knows he has two things that he has to do. Number one, he has to send out a message called a link state advertisement to everybody else in area 51. And in that link state advertisement, he has to say, hey, here I am. Here's my name. We call that the advertising router. Here's my name, and here's the links I have in area 51. And let me describe those links to you, what type of links they are, what the cost is, maybe what neighbors I have on those links. OSPF gets very specific about who it is and what it's connected to. So that's its first job. It has to advertise itself into the area so everybody else can get his jigsaw puzzle piece and put it into their map. Secondly, he has to learn what the area looks like from everybody else. So he has to collect inbound link state advertisements from everybody else so that he knows where they sit, who they're connected to. So ultimately, he knows what area 51 looks like. So when you're a router and you have a link in an area, you know all the fine nitty-gritty details of that area. Now, like I mentioned just a few minutes ago, I could have designed this entire topology here in just one giant area. I could have put everything in area 51, and that would have worked. But here's the downside to this. So if you think of these LSAs as like individual pieces of a jigsaw puzzle, okay? If I had, let's say, 45 routers in one big area, okay? So that's a lot of LSAs I would collect. I'd have my own LSA describing my links, and I'd have 44 other LSAs I'd get from all those other guys describing themselves. And then it would take a little bit of computational power in my brain as a router to piece all those together into a jigsaw puzzle, basically what we call the shortest path tree, into the tree of what that area exactly looked like. And I say, okay, great. So it takes a few seconds to put that jigsaw puzzle together. Well, here's the problem. OSPF has a lot of rules built into it. And one of the rules of OSPF says if another LSA comes in later on, an hour later or a week later, and it says something has changed in this topology. It could be a brand new link was just added to the area. It could be that something about an existing link changed. Either way, if a new LSA comes in, every router in that area has to tear apart that nice tree they've built and then rebuild the tree again from scratch, factoring in that new LSA. It's kind of like you have a jigsaw puzzle all nicely built, and all of a sudden you look in the box and you say, oh, wait a second, here's a piece I didn't see before. Well, instead of just looking for the hole in your jigsaw puzzle about where it goes, you got to rip that whole thing apart and then rebuild it again from scratch, factoring in that piece that you didn't see before. That's what OSPF has to do. So consequently, if I have all my routers in one area, if there's any instability in that area, any particular link that's flapping, for example, like 20 years ago or so, dial-up links were very prevalent, right? When people were working from home or calling up their internet service provider, they would dial up using an ISDN line or a modem line or something. A link would come up temporarily that they could then do networking across that link. Well, that dial-up link, when it came up, if there was OSPF running, guess what happened? Now there was a new link that was just added to the area. So a new LSA would have to be flooded out, and everybody would have to tear apart their tree and rebuild it to factor in that dial-up link. Now, what if you had hundreds of dial-up links coming up, going down, coming up, going down? You can imagine that all the routers in that area, their CPUs would not be very happy because they have to tear apart their tree, rebuild it over and over and over again. So that's the downside of having everything in one giant area, is that your CPU could start crawling if there's any instability in that area, causing LSAs to be reflooded again. So for that reason, the designers of OSPF said, hey, you know what? If you want to, you can take your big topology and subdivide it into different areas. You could have, so one area will be area 0, that's your backbone area. And then you can have other areas connecting into area 0. Like here, we've got area 0 on the left, we've got area 51 on the right. So in this particular case, I could say, hey, I know that area 51 typically has some instability. That's where some links are flapping. So why don't I sort of subdivide that area off by itself, call it its own number, 51, and then I'll make area 0 its own area, and that's nice and stable. So any link flapping that happens over there in area 51 will not affect area 0. Now, to explain that, now we have to go into this discussion about LSAs and who creates them and where they go. So let's start with that. So OSPF LSA, so when I send you an OSPF LSA, it's actually contained inside of an OSPF packet type called a link state update. Just like there's RIP updates, BGP updates, EIGRP updates, those are all the names of certain types of packets. OSPF has a link state update. And when I send you a link state update, there's going to be one or more LSAs inside of that link state update. Now, so when I send you a link state update, one of the very first things you'll see is the type of LSA, because there's different kinds of LSAs and they're designated by number. So the type of LSA I've just been describing, where you're telling everybody in the area about yourself, you're telling them what kind of links you have, what your name is, who your neighbors are. We actually have a name for that. That is called the Type-1 Router LSA. The Type-1 Router LSA. So every router running OSPF, I don't care what other role he might have, whether he's a designated router, an ABR, an ASBR, that stuff doesn't matter. If a router is going to run OSPF, at a minimum, he has to create a type 1 router LSA. And he does that for every area he's connected to. So for example, router 2 that we were just looking at right here, he's what we call an internal router because all of his links are inside or internal to one area. So he is internal to area 51, right? Same thing with CSR2, same thing with router 1. Those 3 routers are internal routers. So each of those routers is going to create one single type 1 router LSA. And their type 1 router LSA is going to describe their links. So let's take a look at one. Okay, so let's go into it. So let's focus in on router 2 since we're talking about him. And by the way, what I would advise you at this point, if you haven't already done this, bring up some like screen grab tool or something. It might be easier for you if you just take a capture of this topology diagram. So when I go into the actual routers and start issuing commands, you can look at this picture and sort of go back and forth and relate to that, okay? All right, so do that for the next couple seconds or so. I will come back to this, by the way. All right, so let's take a look at router 2. All right, so here we are in router 2. And the way that you see the OSPF LSAs is that routers store their LSAs in something called a Link State Database. And there's several different commands to see the Link State Database, from one command that just sort of shows you sort of a high-level snapshot of everything, sort of a summarized view, to other commands that show you nitty-gritty details of everything that's in there. So sort of the first command you'd probably learn is show, and by the way, clearly I'm doing this in Cisco iOS, so if you were doing it on a Juniper router or an Ubiquity router or something, the command would probably be similar. Show IP OSPF database. So this gives you a high-level overview or a summary view of all the LSAs that you've got. Now, the Link State Database is divided into areas. In other words, right now we're talking about router 2. The only area he's concerned with is area 51 because all of his links are in area 51. So his database is going to have all the LSAs he's learned from area 51. However, if I went back to this picture here, if we looked at the database of CSR1, he's an area border router because he's got one or more links in area 0 and one or more links in something else. That's what qualifies a router to be an area border router. So when we look at his link state database, we'll see that he actually has it divided into 2 subsections. When we do that same command, show IP OSPF database on CSR1, we'll first see all the LSAs he's learned in area 0, the backbone area, and then if we keep scrolling, we'll see all the LSAs he's learned in area 51. It's like he's subdivided the link state database into 2 sections for the different areas that he's in. But for router 2, so notice up here, it says, let me just get a different color here so we can see that. So show IP OSPF database, and it says area 51, area 51, area 51. So these are all the LSAs he's learned in that area. So we can see from this right here shows us how many type 1 router LSAs that he has received. Okay, so he has received 1, 2, 3, 4. He's got 4 lines, 4 router LSAs, which makes sense because, you know, if we go back to our picture for a moment, we can see that in area 51, there are indeed 4 routers. So it makes sense that each one of those routers would create a type 1 router LSA. Now, when you're looking through the link state database, like we are here, notice that one of the fields, the second column down, is the advertising router field. So when I, as a router, create a router LSA, a type 1 router LSA describing my links in this area, I put my name on it, and I put that as the advertising router. Now, where do I get that name from? That name comes from my router ID. Now, if you spend any time studying OSPF, you'll know that the OSPF router ID technically is not something you have to manually configure. You've probably learned that as long as the router basically has an IP version 4 address somewhere on itself, on its box, it will be able to dynamically pick for itself its OSPF router ID. And you can see the router ID by just typing, well, there's several commands that show it. You can type show IP OSPF, and the router ID is right there on the first line. Okay. You can type show IP protocols. I think it shows up in there too. Yep, right there. Router ID. Now look at these router IDs here. Let's go back to his Link State Database for a second. Those are clearly not IP addresses. I intentionally created those router IDs manually, and this is why. Let's say you were troubleshooting the Link State Database. You said, hey, you know what? I looked at my routing table. Let's take a step back. I've gotten a bunch of complaints from some people in my network, and they're saying they can't hit this server over here, okay? I know that server is on the 75 network, 75000. So probably the first thing you would do is go into some router somewhere and type show IP route, and you say, oh, the 75 network isn't there. It's not in the routing table. Well, the next thing you'd think about is, okay, well, I'm running OSPF, so I should probably look at my Link State Database to see, do I have an LSA describing the 75 network? If I do, but it's not in the routing table, that will lead me down one direction of troubleshooting. If I don't have the LSA in my table, in my database at all, that will lead me in a completely different direction of troubleshooting. Well, let's say that you saw that in there. Okay, well, now the next thing you want to know is, okay, who advertised that LSA? If you allowed all of your 30, 40, 200 routers to just dynamically pick IP addresses for themselves as their router IDs, and you saw, oh, I've got an advertising router of 192.168.5.90, another advertising router of 36.4.2.2. That's kind of hard to figure out, oh, 36.4.2, where is he? Is that the router over in building 1? Is that the guy over in building 6? But by deterministically setting your router ID, now when you look in your Link State Database, it makes it a lot easier to see where these LSAs came from. So the way I've sort of done this here, and you can see this on the topology diagram, I've deterministically set the router IDs where they start out as 0.0 x.y, where x represents the area that that router is sitting in, and y is the device number. Now, if a router is in 2 or more areas, if he's an ABR, then it's 255.255.0.router number. So you can see now that these actually make a little bit more sense. For example, this LSA, this router LSA on this line here is owned and was advertised by router number 1, who is in area 51, right? This one right here came from my first ABR, 255.255.0.1. You might be saying, but Keith, how do I do that? How do I deterministically set the router ID like that? Real easy command. So when you type, I'll just skip here, show run section OSPF, that's this command right here. Under your router OSPF statement, it's just the router-ID. So I've deterministically set my router IDs so the output of my database will be a lot more meaningful to me. Okay, so right now we're focusing on type 1 router LSAs. And we can see in area 51, I've received 4 of them. Now, this is also something that's sort of unique about this kind of LSA versus all the other LSAs we're going to talk about. You see, once again, if I'm a router, well, let's take a look at router 2. Okay, so router 2, where are you? There you are, right there. Okay, so we see that router 2 has got 3 links in area 51. So when he creates his type 1 router LSA, inside that one LSA, he's going to describe all 3 of those links. If he had 15 links, a whole bunch of sub-interfaces and loopbacks and stuff, they'd all be packed into that one type 1 router LSA. Now, what's unique about that is that every other LSA we're going to look at, for example, when we go over here to CSR1, okay, and when he says, oh, I need to advertise this network here into this area. Well, he's not going to use a type 1 router LSA for that. He's going to use a different kind of LSA. But what I will tell you is whatever LSA he picks for that, that LSA will only advertise this one link, this one network. And then he'll advertise this link in another LSA. And he'll advertise this link in another LSA. So you see, the type 1 router LSA is the only one that has the capability inside that one single LSA to advertise multiple links. All the other LSAs just advertise one thing, and that's it. So let's dig into his type 1 router LSA here. Let's go into a little bit more details here on router 2. All right. So there's a variety of ways you say, okay, I want to see some more details of this. let's start by looking at the router LSA that router 2 created himself. Because remember, another rule of OSPF is that within an area, every router has to have the exact same set of LSAs. In other words, if I've got 6 Type-1 Router LSAs describing this area, you have to have those exact same 6 router LSAs, which makes things like route summarization and route filtering pretty much impossible within an area. And that's another downside of having all your routers in one area. You might say, oh, Keith, my network's totally stable. No links ever go up, ever go down, so there's no harm in having my 40 routers all in area 20. Okay, you're right. Your CPU is not going to have a problem with that. But because we have this rule that all the routers in an area have to have the exact same link state database, now what you've just prevented yourself from doing is you're not going to be able to do any kind of route summarization or route filtering within that area. You just lost that ability. The only time you can do that kind of thing is when you have multiple areas and you can go to the guy who's straddling them, the ABR, and you can do your route summarization, you can do your filtering on him. Okay? All right, so let's start by looking at the router LSA that router 2 created himself. So we can type show IP OSPF database. Now, if I do a question here, when you know the name of the LSA, for example, router, you can select that. So router, that's the Type-1 Router LSA. And I can say self-originate. So I'm telling router 2, show me all the router LSAs that you have created yourself. All right, so here we go. He says, hey, here's the router LSA I created, and I flooded into area 51, and I kept a copy of it myself. He says this LSA has been around for 927 seconds. By the way, LSAs are only good for 1 hour. They're only good for 3,600 seconds, and that's it. So as a router, when I create an LSA, whether it be a Type-1 Router LSA or any other kind of LSA that I create myself, by default, once I reach the 30-minute mark, I will actually flood it again. Notice down here that this LSA has a sequence number, right? Now, if we saw, well, I think that's like, what, 80 million or something like that? The very first sequence number is like 80,000,001. So if you ever saw 80,000,001 there, that means this LSA is brand new and it hasn't even been around for 30 minutes yet. After 30 minutes expires, now it says, okay, I'm going to increase the sequence number to 80,000,002, and I'm going to send it out there again. And every 30 minutes, even if nothing has changed, I will increment the sequence number and reflood it. And so all the other routers then will get that same LSA. They'll say, oh, I've already got a copy of that, but this sequence number is higher than what I have. So they'll purge the old one they have and put in the new one and start their 1 hour clock all over again. Okay, so we know that an LSA is only good for 927 seconds. Show IP OSPF. Let's see what the oldest one is in here. I think if we do this command, we see the ages. Yeah. So these are fairly new. So none of these look like they're, so this is 1785 here. So this one's going to be refreshed pretty soon. So router 2 in area 51, he's reaching the 1800 second mark, right? That's 15 minutes, if I'm doing my math right. 3,600 in half is 1,800. So at 1,800 seconds, we'll see this one drop down to 0 again, and the sequence number will change from 80,000,002A into 80,000,002B. And heck, maybe by the time I've been talking here, that's already happened. Oh, he's close. Okay, he's not. He should be doing it any time now. But let's go back to router 2. Okay, so there's the age. There's the link state options. So for example, this guy is saying, I don't support type of service capability. And he says, I do support OSPF demand circuits. If anybody wants to do that, you won't see that a whole lot. He says, okay, link state type, router links. Now, if you had actually captured this in a sniffer trace of like Wireshark or something, you would see this field would have the number 1 in it. And 1 is called a router LSA. Okay, every single LSA has a link state ID and then link data. Now, what's in the link state ID and what's in the link data depends on what kind of an LSA it is that we're talking about. So in a Type-1 Router LSA, okay, his link state ID is his name, his own router ID. So we can see that's a copy right there, right? Advertising router is the same as link state ID. We have the sequence number. That gives us sort of an idea of how long this LSA has been around, because we know it starts at 80,000,001. So we have a checksum here to see if this has errored out in the header or not. And we have number of links, 3 links, which when we go back to router 2, that makes sense because we can see he's got 3 links. Now, how's he described these? All right, so before I go back to this is something else. Remember how I said that OSPF is very specific about how it describes links. So when I tell OSPF, I want you to operate on this link right here, whether I do it with a network statement or whether I went right to the interface and I type the command IP OSPF 1 area 0 or whatever it is. When I tell OSPF to operate here, one of the first things that OSPF does is he says, what kind of a link is this? And he answers that by looking at the encapsulation type. He says, is this Ethernet? Is this the point-to-point protocol? Is this HDLC? Is it frame relay? Is it, what is it on here? What layer 2 encapsulation is on that link? Based on his answer to that question, we'll determine how he describes that link to other people, how he decides if he's able to discover neighbors on that link or not. So, EIGRP, RIP, they don't care about that, right? All they say is, what's the network? That's what I'm going to advertise. They could care less what kind of link it is, but OSPF is very specific about that. OSPF will then also say, okay, in addition to what kind of link this is, as I start sending out hello packets, am I getting any hello packets back? That also depends on things, because if I start sending out hello packets, there's a window of time. Well, let's just take a step back here. If I start sending out hello packets and I never get anything back, like for example, let's say I'm a router and this link is connected to a switch and there's just a bunch of laptops and servers on that switch, but there's no other routers out there. So as far as this network segment is concerned, I'm it. I'm the only router. Then I would say, okay, I'm sending out hellos, but I haven't formed any adjacencies with anybody else. So I will categorize this link as what's called a stub link. So a stub link means I am not talking to anybody else. It's just me here on this link and nobody else. Whereas if I form a neighbor relationship with somebody, then that means I categorize the link a little bit differently. Let's take a look at this. All right. So from router 2's perspective, he says I have 3 links. He says all 3 links are transit networks. Now, what is a transit network? A transit network is a network segment, if you can imagine this, a network segment where as packets are passing through it, it's possible that neither the source nor the destination of those packets is meant for this link. All right? For example, let's look at the opposite of this. Let's look at the stub link I just talked about, right? If I have a link that's a stub link, is it possible that a packet could be on that link where neither the source address nor the destination address has anything to do with this subnet at all? That wouldn't be possible, right? Because if packets are being transmitted onto that link and there's no other routers out there, then that means the destination address, whatever it is, would have to be whatever this subnet is, right? Why else would I put a packet on this wire if the destination was not this subnet? Similarly, if I was receiving a packet, wouldn't the source IP address have something to do with this subnet right here? So that's a stub network. A stub network means, hey, either the destination or the source, one or both, is going to be whatever this subnet is. Whereas a transit link, imagine 2 routers and packets are passing through. Well, on a transit link, the source and destination quite possibly has nothing to do with whatever subnet's on this link itself at all. So that's what this guy is saying. He's saying, look, I'm a router, I'm connected to another router, and because I'm connected to another router, there could be packets passing through this link that have nothing to do with this link itself. It is just a transit path. It's just a highway to get from one point to another. That's all it is. So in this router LSA, he's describing this as transit because he's formed a neighbor relationship with somebody else. Now watch this. I'm going to do this here for a second. Even though this picture makes it look like these routers are physically directly connected, they're actually not. There's actually switches in between them. So I'm going to go onto CSR1, and I'm going to shut down this interface right here. Now this interface on gig 01, that will stay up because it's connected to a switch, but he will lose his OSPF neighbor. So now he's going to say, I still have this link here, but I don't have any other neighbor on it, and we should see it. It might take a little bit of time, but we should see that in his router LSA, he changes it from describing that link as transit to now describing it as stub because there's no other router right there. So let's take a look. Let's just try that experiment. So on CSR1, I'm going to shut down gig 2. All right. Let's go back to router 2. Show IP OSPF neighbor. Now remember, neighbors have timers, right? We have to wait for the dead interval to expire before he says, oh, I guess that neighbor's gone because I haven't gotten OSPF hello packets from him in a while. All right, so it's the one in the middle there. See how it's 16 seconds? That will continue to go down, 10 seconds. And just a few seconds, he'll realize, oh, that neighbor's gone. I haven't gotten anything. All right, we should see a message any second now where he says, I've lost my neighbor. There we go. It's gone down. Okay, so let's see. Did that change the way he describes his router LSA? See that? Look at that. There it is. It's no longer considered a transit link anymore. Now it's considered a stub because it says, I'm the only one out here. Now, also, not only did he change how he's describing the link, this also changes what characteristics of this link he's telling everybody else. For example, let's look at right now. So when it's a stub link, the router says, I'm the only one here. There's nobody else that can describe this link but me. So in his router LSA, look what he does. He says, I'm going to tell everybody what the IPv4 subnet is, and I'll tell everybody what the subnet mask is. So everybody else in Area 51, they now know that A, there's a router out there with the name of 0051.2. So they can put a point on their map saying, there's that guy right there. They can say, B, he's got a link, and that link is a stub link. So it's like, here's the point, and then it just goes nowhere. And they can say, on that stub link, here's the route, the 2121 network /24. And now they can put that into the routing table. Now, how did he describe that exact same link back when he did have a neighbor relationship and he was categorizing it as a transit link? Well, let's go up here and take a look at that. Right there. All right, so back when it was a transit link, he described it differently. He said, okay, now here's what I'm going to do. I'm going to give the IP address of my interface connecting to this link. My interface is 21.21.21.2, and I'm going to give the router ID. Is this the router ID or the, I don't think that's, no. I'm going to give the IP address of the designated router on that link. So the designated router's address and his own IP address. So what that does is when everybody gets this router LSA in Area 51, now they know, okay, there's a guy out there whose name is 0.0.51.2. We can put him on our map. We know he has a transit link going to another router. He's just told us that his own IP address is 21.21.21.2. And he's also told us that the designated router is 21.21.21.2. So guess what? He must be the designated router on that link. So we really don't know anything about this guy. We know that he exists because that would not be classified as a transit link if he did not have an OSPF neighbor relationship, but we don't know really anything about him. So this was good enough for us to start building this graph, right? We also know that he's got another transit link going to somebody else, and same type of thing. On that link, he is the DR, and there's his information, and we know he's got another link going to some other router. Now, in this case, it's a little bit different. He says, okay, my address is 22.2, I'll just put .2 right here, and the DR is .1. So we know a little bit more about this designated router. So all the routers in Area 51 now, they have been able to put this piece of the jigsaw puzzle together, just like this. But notice, from a routing perspective, extracting routes and putting them into the routing table, is this going to help us? No, because we have no subnet mask information here. You can't figure out the prefix on a link without knowing what the subnet mask is that goes along with that link. So on router LSAs, when you're describing transit networks, that's good enough to build the topology. It's not good enough to help all the routers know what subnets reside on those links. So we need another type of LSA to do that job. And that's going to be the Type 2 network LSA. That's going to be the designated router's job to create another LSA to do that. Before I go to that, just a couple other things here about the Type 1 router LSA, and then we'll leave this guy in the dust here. We'll leave him behind. All right, so far we've looked at the router LSA is capable of advertising transit networks. Right, that's a link where there's me and I've got an adjacency with somebody else. That's a transit network. Also, a transit network is actually categorized by two things. Number one, I've got a neighbor. I've got an OSPF neighbor, but that's not the only thing. Number two, the encapsulation type. The encapsulation type equals either broadcast or non-broadcast multi-access. Basically, which is either Ethernet, token ring, probably won't see token ring anymore, or frame relay. So if a link is running Ethernet, any flavor of Ethernet, gigabit, fast Ethernet, whatever, any flavor of Ethernet, token ring, I guess you could also put in here for your old timers, FIDI. Ethernet, token ring, FIDI, or frame relay, all of those would fall into either the category of broadcast or non-broadcast multi-access. They'd be one or the other. So if I have a link that's broadcast or non-broadcast multi-access, it's one of these four things, and I have a neighbor on that link, that is a transit network. If it's any of those things, but I don't have a neighbor, it's just me, that is stub. What else could it be? Well, there's also point-to-point. Now, in this particular environment here, normally we'd see point-to-point links with like serial interfaces or something. So I'm just going to replicate a point-to-point link real quick. So what I'm going to do is I'm going to go back to CSR1, whose interface is down right now. So that's gig 2. All right, I'm still in there. I'm going to say, hey, when you come back up, I'm going to tell you what kind of OSPF network type you are. I'm not going to let you figure it out for yourself. So IP OSPF, if I could type, SPF network point-to-point. Okay, and let's just no shut. Now, right now, there's going to be a mismatch, right? Because one guy's going to say point-to-point, one guy's going to say, I'm not point-to-point, I'm broadcast, and that's going to be a mismatch of link types. So we need to fix that by going to router 2. And on router 2, that is interface gig 01. Let's shut him down temporarily. IP OSPF network point-to-point. No shut. Okay, so now, If we had been talking about a link type that was naturally point-to-point due to the encapsulation, like if it was HDLC or PPP, I would not have needed to do this. He would have naturally said, oh, those protocols were designed for point-to-point connections where it's just me and one other router and there's no possibility of anybody else. But this was an Ethernet segment, so I had to sort of trick him into thinking it was point-to-point. So now when I look at his OSPF database, the one he created. Actually, hold on a second. Show IP. Actually, we could do it like this. So let's go back up to this again here. You'll notice something that looks a little odd. Now, right now, we are on router 2. And notice up at the top here, it says number of links 4. 4? If we look at our picture, router 2 has only got 3 links in Area 51. There they are. 1, 2, 3. Why the heck is he advertising 4? Well, with point-to-point links, let's go back to this. The designers of OSPF said, okay, a point-to-point link technically doesn't even need IP addresses on either end. Like in the world of Cisco, you could use the IP unnumbered command. I could say on my, if I was talking about like a serial interface or something, instead of putting an IP address on this link, I could say IP unnumbered loopback 0 or IP unnumbered fast Ethernet 00, which means, hey, if I'm originating packets on this link, I'll borrow the IP address of my loopback or I'll borrow the IP address of my fast Ethernet and I'll use that as my source address when I send it out there. But technically, this link doesn't have its own unique source address. So if that was the case, if I did not have an actual IP address on my point-to-point link, I was borrowing it with like an IP unnumbered command, then in my router LSA, this link would be described one time as a point-to-point link. So it would just count as one link in the world of OSPF. But if I do put a subnet on top of this, if I say, okay, I'm actually going to put an IP address on this interface, maybe a /30 or something, then the designers of OSPF said, okay, now, even though it's a point-to-point link, we have to describe it as 2 links in the world of OSPF. We're going to describe it as a point-to-point link, or we're going to give the characteristics of it, and then we're going to describe it again, giving the IP information. And so that's what we see right here. So remember, what are we talking about here? We're talking about this link right here. That's what we're describing. So look at how he describes that now that I've converted that into a point-to-point link. Right here. First, he describes it as point-to-point. He says, okay, here's what I'm going to tell you. I'm going to tell you my neighbor's router ID, and I'm going to give you my own IP address. That alone would be enough to fit the jigsaw puzzle together, to sort of put that line in place. But it's not enough for routing. So he describes that same link again, this time as a stub network. And a stub network, he says, I'm going to give you the subnet and I'm going to give you the mask. So that gets a little bit weird. You know, when you take a look at show IP OSPF database, and you look at it and you say, okay, I know this guy, that's router number 2 in Area 51. I got my picture here. He's got 3 links. You say, whoa, 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 he's 4 links. What? That's why that would show up. Because if you see more links in your link count here than you're actually seeing in your topology diagram, it's probably because one or more of those links is being described twice. It is a point-to-point link with an IP subnet on top of it. So it has to be described twice. All right, so I think that's the only other thing here I want to mention about the router LSA is let's take a look at show IP OSPF database router. And instead of looking at my own on router 2, why don't we look at the one from advertising router? Let's look at the ABR's router LSA, because there's one unique thing in here I want to point out. Notice that in the LSA itself, in the LSA header, there's a couple of flags you can set if you are doing something special, like if you're an ABR. If you're an area border router, there's actually a little bit in there that you flip from 0 to 1, and that advertises into the area, hey, everybody, I'm an area border router. If we had a router serving as an autonomous system boundary router who was redistributing routes, there's another bit he would flip in his router LSA so everybody would know in his area that he is an ASBR. All right, so I'm going to pause here for just a second, and I'll tell you this. This Type-1 Router LSA that we've been talking about for about 45 minutes or so, this is probably the single most difficult LSA to comprehend because it's got so many moving parts and so many components to it. Once you wrap your mind around the router LSA, everything else is pretty much a piece of cake after that. So let's leave the router LSA behind. I'm just going to leave this as a point-to-point link right here between CSR1 and router 2. Now, I mentioned that, let's take a look at this link here, right? So this is Ethernet, which means it's broadcast. And because he has a neighbor with CSR2, he's going to describe that as transit. And I said that when your router LSA describes a link in that way, when he says, I have a transit link, we said, okay, what do? Well, you give your own IP address, which in this case would be 22.22.22.2, and you give the IP address of the designated router on that link. But I said that alone is good enough to build the tree, to factor this part into the tree, but it's not good enough for procuring a route, for the route in the routing table. And if you remember, I said, now we need another type of LSA. The designated router on the link has to create what's called a Type 2 network LSA. So let's take a look at this link right here. Our first question is, okay, who is the designated router on that link? Well, there's several different ways we can answer that question. What I'm going to do is I'm going to go back onto router 2 here, that's gig 00. And I'm going to say show IP OSPF interface gig 0/0. And in the output, it will tell me who the designated router is. And it will say designated router is, it's not me, it's the other guy. It's CSR2. Right, so here's me, I'm router 2 in area 51, so I'm the backup. The DR is this. Okay, so that designated router should have created a Type 2 network LSA. Show IP OSPF database. And here it is, okay? So we actually, remember, this is all the Type 2 network LSAs we received for the entire area. So we can see here that in Area 51, we've received a total of 4 Type 2 network LSAs. It looks like CSR2, so that's this guy right here on the far right. He is 0.0.51.22. That's this guy right here. Apparently, he is the designated router for this link and for this link because he created 2 Type 2 network LSAs. There's one, there's the other. And so let's dig into that. Show IP OSPF database. Now we want to look at network because that's the name of the LSA, Type 2 network LSA. And I don't want to look at all of them. I want to look at the one from advertising router 0051.22. Okay, so here are his 2 network LSAs for Area 51. He says, okay, I own it. That's me. Here's the actual IP address of the designated router, and here is the mask. So using these 2 components, now we have a route. He says, oh, by the way, here's the routers that I'm adjacent to. Here are my neighbors on this particular link. So using that Type 2 network LSA, now all the routers can extract the subnet and the mask from that particular link. So only designated routers create that. If we had a point-to-point link, well, we saw that with a point-to-point link, we don't have a designated router. Both routers describe the link as point-to-point, which helps build it in our tree, and both routers on either end of that point-to-point link also describe it as a stub link, which gives the network number and the subnet mask. So that the router LSA in a point-to-point link was enough for us to extract the route. But it was not enough in a transit link. So we needed a Type 2 network LSA to give us that additional information about the transit link, what prefix and subnet mask live there. Okay, now, if all of my routers were in one big area, I'd be done. I would have my SPF tree completely built based on Type-1 Router LSAs and Type-2 Network LSAs. And between those two, I would be able to extract all the routes that live in my area, what their subnet masks are, and I'd be able to populate my routing table. Now, however, Type-1 Router LSAs and Type-2 Network LSAs, while they do get flooded within the area, they are not allowed to go into other areas. So if we look at our picture here again, so as this guy's creating a type 1 and maybe some type 2s, as this guy's creating a type 1, this guy's creating a type 1, maybe some type 2s, they're being flooded around, they're all getting each other's LSAs, but once they reach this point right here, they stop. CSR1, he is an ABR, he is touching Area 51, so he will collect those LSAs and he will put them in his Area 51 database, but he will not allow those LSAs to go any further than that. Those are not allowed to go into Area 0. Because the people in Area 0 could care less about that. The routers in Area 0 say, look, the only tree we're trying to build and maintain is our own tree for Area 0. We don't care about the trees in other areas. So that leads to the next logical question, which is that, okay, if everybody in the green box here knows what that topology looks like and they know what their networks are, but the people in the red box, Area 0, they have no knowledge of Area 51. They don't even know Area 51 exists. Now, they know this guy's an ABR because when he creates his Type-1 Router LSA, he flips a little bit in there saying, hey, everybody, I'm an ABR. But he does not tell them what other areas he's connected to. So all they know is he's connected to something else, but we don't know what. Well, it's CSR1's responsibility to extract the networks and subnet masks that he learned and all these Type 1 and Type 2 router and network LSAs that came into him this way. He has to extract the routing information from that and inject that into a different kind of an LSA called a Type 3 summary LSA. Now, don't think route summarization. This has nothing to do with route summarization. What this is CSR1 is saying, hey, everybody in Area 0, I'm not going to tell you what the area number is of Area 51. So you don't know that Area 51 exists. I'm not going to tell you anything about that area. You have no idea what the internal structure is of that area. I'm just going to summarize what you need to know. All you need to know about that area over there is what routes live there and that you can get to them through me. That is why they call it a summary LSA. So let's take a look. And same thing's going to happen. All the routes that live over here, CSR1 has learned those via Type 1 and Type 2 LSAs, and he has summarized that information into Type 3 LSAs, which he has injected into here. So while I'm still on router 2, I can see that. So first of all, here on router 2, if you look at show IP route, OSPF, all the routes that you have that just have a little O in front, those are OSPF intra-area routes. In other words, those are routes that you learned because you received either a Type 1 router LSA or a Type 2 network LSA from your own area. That route lives in your circle. All these ones that say OIA, those are inter-area routes. These are routes that you learned because you received a Type 3 summary LSA from an ABR. So let's take a look at that. So show IP OSPF database. These are a lot easier to read, these Type 3. So here we are, summary networks. So that's a Type 3 summary LSA. And you can see they all were originated by the ABR. So he's the one that created them. And this actually tells us the network IDs that he's advertising. Now we can dig into the guts of that too. We can say show IP OSPF database summary. I'm looking for Type 3 summary LSAs. And if I just hit enter right now, if I had like 5 or 6 ABRs all connecting me to Area 0, I'd see all the Type 3 summary LSAs. I don't want to do that. I only want to see the Type 3 summary LSAs that were advertised by this guy. Oh, okay, so what did I do wrong here? I put a 0, 1. Should just be 1. I did that incorrect. 0.1. There we go. He says, okay, I'm the ABR. So right here, this is my router ID. He says, hey, everybody in Area 51, you know who I am because I previously sent you a Type-1 Router LSA. I told you about myself. I told you about my links in Area 51, so I'm already on your tree. You know how to get to me. He says, so here, I'm telling you about myself again, but this time, I'm telling you about a network that's behind me in another area, the 123 network. Oh, and here's the subnet mask, and here's the OSPF cost for that. All right, and here's another one down here. Another thing you could do is, let's say you were troubleshooting and you'd show IP route OSPF and you were looking for, let's say, the 333 network. Now, let's say it was not there. You said, what's going on? The 333 network should be in my table, but I'm not seeing it. So you'd say, okay, let's see here. I'm on router 2 right now. Where is the 333 network? Oh, it's way over here. Okay, so that means that if router 2 got an LSA for it, he would have gotten a Type 3. So I'm not going to look at my router LSAs. I'm not going to look at my network LSAs. I'd be wasting my time looking at those, trying to spot the 333 network. I should be looking for a Type 3 summary LSA. So here's what you can do. If you know in advance the type of LSA that would be carrying the route as well as the route itself, at least for Type 3s anyway, you can do this. You can say show IP OSPF database summary, and then you can actually say, this is what I'm looking for, 3330. And sure enough, I have it. So if it was not in my routing table, but now I have proof that I actually did get a Type 3 summary LSA from the ABR, that would lead me down another path of troubleshooting. Why do I have the LSA, but it was not converted into a route? Could be a variety of reasons why that could be. But this proves that you got the LSA. All right, so if all of my routers in my entire company were split up between Area 0 and other areas, I'd be done. I'd have Type 1 router LSAs, Type 2 network LSAs, and Type 3 summary LSAs, and that's all I would have. And those 3 LSA types would be sufficient to describe my area as well as all the routes in other areas that I don't know about. What if, let's go back to our picture here, what if we have some other router, like switch 2 here, who's receiving non-OSPF routes? Like he's receiving EIGRP or RIP routes, or maybe he's got some static routes, basically routes that are outside of the OSPF domain. And he needs to inject those into OSPF. Well, he's going to use a different type of LSA for that, which is the Type-5 External LSA, because these routes are external to the OSPF domain. So we can see evidence of that in our routing table. Show IP route OSPF. Those show up normally as OE2s. These are called external routes because they came from Type-5 External LSAs. So when you see that, that means that route came from some autonomous system boundary router somewhere, and he's doing redistribution. He's maybe redistributing EIGRP or redistributing RIP into OSPF. He's basically taking non-OSPF routes, converting them into OSPF. So if we go up to, I think that was switch 1. Here on switch 1, we can see here in switch 1, okay, he does not have that command in there, so we need to do that. So show IP EIGRP neighbor, make sure he's running EIGRP, yep. Okay, so router OSPF1, redistribute EIGRP 100. Okay, actually, before I do that, watch this. Router OSPF1, no redistribute EIGRP 100, so stop that. So right now, he's just a regular old OSPF router. Show IP OSPF database router self-origin. Show me your router LSA. Okay, so apparently he is missing some stuff. Oh, wait, I'm on switch 1. Should have been on switch 2. Oh, okay. No router OSPF 1. We're done with you, router 1, or switch 1. Let's go over here. Helps to have a topology diagram in front of you. Show, run, begin router, begin router. Someday I'll learn to type. All right. So this is switch 2. I'm on switch 2 right here. And we can see he is an autonomous system boundary router, sometimes called autonomous system border routers, because I'm taking EIGRP routes and converting them into OSPF External LSAs. So if I go into any router and I look at his OSPF database, now here's something else that's kind of unique about Type-5 External LSAs. All the other LSA types, types 1, 2, 3, and we haven't talked about 4 yet. We have to talk about 5s and then backtrack to 4. All those are stored in the section of the database where you learned them. For example, my type 1s, type 2s, type 3s, type 4s, if I'm sitting in Area 51, I have an Area 51 database. That's where I put that stuff. If I'm also sitting in Area 0, I got another Area 0 database. The type 5 externals, these are kind of unique because whenever a router sends out, like let's say this guy sends out right here, if he sent out a 1, a 2, a 3, or a 4, those go into his area and then they stop at the border of his area. So 1s, 2s, 3s, and 4s cannot traverse from one area to the next to the next. They can't do that. They're meant to be flooded within an area and then that's it. They stop. So for example, if I had, let's say, another area up here, let's say we had area 2, and let's say we had this guy who was an ABR, okay? So it would be his job to take all the routes that he learned about in area 2, and he learned about those as type 1 router LSAs, type 2 network LSAs, and he would send those into area 0 as type 3 summary LSAs. We just saw that. Now those type 3 summaries LSAs would be flooded throughout area 0, and then they would stop right here at this other ABR, CSR1. Now you might be wondering, well, wait a second. Okay, so now area 0, their routing tables know how to get to the routes in area 2. That's great. But how do the routers in area 51 know how to get to the routes in area 2 if they're stopping right here at CSR1? Well, guess what? When CSR1 gets these type 3 summary LSAs, guess what he's going to do? He's going to pull the route and subnet mask out of those and create his own type 3 summary LSAs. So here go his own type 3 summary, but these will say, I'm advertising router CSR1. So you can see these original ones here, they were not allowed to be flooded into area 51, but the information they contained did make it into area 51 because that information was replicated into CSR1, his own type 3 summary LSAs. Okay? What does that have to do with type 5s? Well, when an ASBR gets some non-OSPF routes and he decides to advertise those as type 5s, that is the one and only type of LSA that goes all the way to the far end of the OSPF domain. So it just gets flooded throughout the entire OSPF domain. It's not the job of the ABR here to copy that into something else. Nope, he's going to put in his database and keep it going. So when we actually look in our OSPF database for our type 5s, we're not going to see them. For example, let's look at CSR1 here. Let's go to CSR1. Show IP OSPF database. So it starts out with everything he learned in area 0. Keep going. All right, he says, okay, I'm done with area 0. Notice in area 0, no mention of type 5s. Talks about his type 1 router LSAs, type 2 network LSAs, and type 3 summary LSAs. These are actually all the ones that he created himself. And then he proceeds on to everything he learned about in area 51, router LSAs, network LSAs, and summary LSAs. And then when he's done, at the very bottom, he says, down here are my type 5s. And notice there's no mention here of area number because these don't belong to any particular area. They belong to the entire OSPF domain. And so he says, okay, the ASBR is 0002, right? So he is a router in area 0, and it's a device number 2 in area 0. And that ASBR is advertising these links right here, these external links. If we dig into that, show IP OSPF database, we can say external. And at this point, I could look at a particular one like saying 12.12.12.0 if I want to look at just that one. Or once again, I could say, hey, show me all the external ones that were advertised by that ASBR. Let's just do that. Okay, so here's one of them. Here's a Type 5 External LSA. We can see here, it gives us the link state ID, so that's the prefix, that's the network. And there's the mask. This is the ASBR that owns this particular LSA. Here's the OSPF cost. And a forwarding address of all zeros means, hey, if you ever need to send any traffic to the 12.12.12 network, send it to me. Send it to 0002. I know how to get it there. Now let's go back to our picture again. So this guy right here, so we know that he is 0002. That's his router ID. Okay? And so we know that everybody in area 0, so there was some link up here. I think one of them was like the 99 link. Okay? So he just created a Type 5 External LSA, advertising that into area 0. And he said, hey, everybody in area 0, you can get to me, 0002. Well, that's great, because in area 0, everybody knows exactly where this guy is, because previously he sent a Type 1 Router LSA. He said, hey, everybody, let me tell you about myself. I'm 0002, and let me tell you about the links I have in area 0. So everybody was able to pop him onto their tree, and they knew exactly where he was. But here's a problem. Those Type 5 External LSAs are also going to continue on this way. Now let's look at CSR2, for example. He receives a Type 5 External LSA, and the guy who originated or advertised it is 0002, and he's advertising that 99 route. Now, if all we had were Type 1s, 2s, 3s, and 5s, this would be a problem, because CSR2 would say, okay, 0002, whoever you are and wherever you are, thank you for telling me about the 99 network, but I don't see you on my tree. When I look at Area 51, which is the only tree I know about, you're not in it. So how am I supposed to know where you are so I can send packets to you? So this alone would be problematic. This is why we have the last LSA we're going to talk about today, which is the Type 4. We call this the ASBR Summary LSA. All right, so what does this one do? Well, remember, way back at the very beginning here, this guy created his Type 1 Router LSA. Type 1 Router LSA. And that's how everybody in Area 0 knew where he was, including our ABR. Now, when our ASBR started doing redistribution, inside that Type 1 Router LSA, he flipped a little bit. As a matter of fact, let's take a look at it. Let's go on to CSR1. Here we are. Show IP OSPF database. Router, advertising router 0002. That's the ASBR. And notice, he said, I am an ASBR. He flipped a little bit saying, I'm doing a special job of redistribution here. I'm an ASBR. The moment that CSR2 got that. He said, ah, okay, in my tree of area 0, I know right there is an ASBR, but I'm also connected to other areas, and they're not going to get this LSA. It stops with me. So I should probably tell these other areas, I should probably tell Area 51, hey, guys in Area 51, you know about me. I'm your ABR, I'm on your tree, and let me tell you, behind me, there's this ASBR. You're probably going to get some Type 5s from him at some point in time. And when you do, I want you to know that even though he's not on your tree, you can go through me to get to him. And that is the purpose of the Type 4 ASBR summary. Let's take a look at that. So here we are on the ABR right now. Show IP OSPF database. So what's he going to do? First of all, he doesn't need to advertise that this way, right? He doesn't need to tell everybody in Area 0, hey, to get to the ASBR, go through me. They already know where the ASBR is. He's on their tree. They got a router LSA from him. So he doesn't need to send it that way. He needs to send it this way. This is where he needs to send his Type 4. So when I go into his database and I say, hey, I want to look for the Type 4 that you created, advertising reachability to this guy. Well, that's going to be in his Area 51 database. It's not going to be in his Area 0 database. So let's look here. So right now, this is his Area 0. It's not going to be in there. We need to keep going down to his Area 51. There's the Type 1, Type 2, Type 3, and right there. Here is the Type 4, the ASBR summary LSA. He says, I own it. I'm your ABR, 255, 255.0.1, and what am I advertising to you? I'm advertising reachability to this guy, the ASBR. Let's dig into that. Show IP OSPF database ASBR summary from the advertising router. Well, I could say advertising router of 255, but since I am on CSR1, I'll say self-originate. And there it is. He says, okay, I'm telling you about the ASBR. I'm the one advertising it to you. So, hey, everybody in Area 51, you can get through me to get to him. So now when a Type 5 makes it down this way, or to this guy, or to this guy, any of these guys here, and they see inside of there that's advertised by this guy here, they'll go back into their database. They'll say, okay, how do we get there? And they'll say, oh, I see a Type 4 LSA that was originated by him, and he said that we can use him to get to this guy. All right, I think that will conclude everything I need to say about OSPF LSAs for today. So at this point, I think we can open it up to any questions that we might have. See, there's a few of them here. All right, let's start at the top. All right, so Sai, you asked a question. You said, how can we troubleshoot if the expected subnet or network is not in the self-originated LSA? All right, so to rephrase your question, so you're looking for a particular network, and you're asking yourself, did I receive an LSA advertising this network? Okay, so you know you're going to have to go into the OSPF database, right? Because that's where all those LSAs are stored. And in a real live production network, that LSA database could literally have thousands of LSAs inside of it. It could be huge. Where do you look? Well, it helps to start by having a topology diagram like this. For example, if I was looking for this network right here, and let's say I'm on this box, I'm on CSR2. Well, with this topology diagram, I can say, all right, number one, the first question you would ask yourself is, the network I'm looking for, does it live in an area that my router is directly connected to? If the answer is no, like in this case, right, it lives in Area 0. CSR2, he's not connected to that. And that means we can rule out the Type-1 Router LSAs, that's not going to carry that route, and we can rule out the Type-2 Network LSAs. Okay, it's not that. Now, if that route is actually in another area we're not connected to, the first place I would look for is a Type-3 summary. So if I was in CSR2 and I'm looking for the 192.168.1 network, let's go to CSR2. I'd say show IP OSPF database summary, because I know it's going to be carried in a Type-3 summary LSA, and then I'd say 192.168.1.0. And there it is. I did get it. Okay? Now, if the network you're looking for, let's go back to our picture. If you say, okay, well, the network I'm looking for does live in my area. So once again, I'm on CSR2, and I'm looking to see if he received this network right here. All right, that gets a little bit trickier because now we know that network is going to be learned either via a Type-1 Router LSA or a Type-2 Network LSA. All right, let's say that it's a Type-1 Router LSA. How would we find that? So on CSR2, show IP OSPF database. Let's just start with this. All right, so notice we can't search for it based on, now if we looked at, this is where knowing the advertising router in advance helps us. If I can look at this topology diagram and I can say, well, I know that I've formed my router IDs this way, right here. So if I'm looking for this, I know that both this guy and this guy should have advertised it. If I can predict what the router IDs are in advance, like in this case, I know that this guy is going to be 0.0.51.1 because he's in area 51, he's router 51. I can search, I'm right here on CSR2, I can search for the router LSA from that guy and see if his router LSA contains that link. So 0051.1, so that's where I would go like this. I'd say show IP OSPF database router, and I want to look for the advertising router of 0051.1. Oh, good. I did receive a router LSA from him, and there it is. Now, if that link was not in there, if I saw his router LSA, but that was not in there, the next thought I'd be asking is, okay, why did he not advertise that link? It's one of two things. Either the link is down, so he's trying to advertise it with a network statement, but the link is down, or maybe I forgot to type in an OSPF network statement in that router. So now I'd have to actually go to that router, do a show run, and look for either of those two things. But the moral of the story is here, if you're trying to troubleshoot, if you're saying, okay, I'm trying to look at my OSPF database for a particular network, you have to know where in your topology that network would be. Is it in your area or a different area? That will help you isolate what kind of LSA should have advertised that route. So Bart has a question. Let's see here. The 22.22.22.1 isn't on the topology. Where did he get that from? Let's see. That's a good question. So Bart, let's go to router 2. It could just be that I screwed up on my IP addressing here. Let's see. 22, that would be, let's go to router 2 and take a look. Oops. Come on. Whoa, what's that? Okay, let's try that again. Show IP OSPF database. Let's just take a look at his router LSAs. And see if we see a 22.1 in here somewhere. 21. Okay, so yeah, I see what you're talking about. So right here, it's probably because I screwed up the topology diagram would be my guess. So he says, designating router is this, I am this. So if these two numbers were the same, that would mean that router 2 himself is a designated router, but because they're different, that means I need to go to CSR2, and I've probably messed up on his IP addressing. Show IP interface brief. Yep, there we go. So CSR2, he's got 22.1, so that's where that came from. Thanks for catching that, Bart. Good eyeball. All right, what else have we got? Mauricio asked a good question. Why? So to paraphrase your question, I think what you're asking is, why isn't the network prefix always added to the Type-1 Router LSA? Sometimes it is, right? We saw how with point-to-point links it was. Show IP OSPF database router self-originate. Oh, this is CSR2. We don't want him. Advertising router 0051.2. Remember, on a point-to-point link, when we described it that second way as a stub, we did put the prefix in there and the mask. But why is it not in here? I think the overall answer to that would be that the primary purpose of the Type-1 Router LSA is to build the tree, for all the routers to know where everybody is, what their advertising router IDs are, and who they're connected to. And supplying like IP subnet information is like a secondary purpose of this. So, ultimately we'd have to ask the original designers of OSPF, hey, for point-to-point networks, you included the prefix in the Type-1 Router LSA. Why didn't you do the same thing for transit networks? I don't know. They decide, hey, we're going to create a Type-2 network LSA instead and put it in there. Why they did that, not entirely sure. Good question, though. Noel asks, is DMVPN considered a non-broadcast multi-access network? That is correct. I don't have a lot of experience and exposure with DMVPN, but I have heard that that is true. The DMVPN is considered kind of like Frame Relay as a non-broadcast multi-access. So that would be considered a transit network requiring a designated router and a backup designated router from the perspective of OSPF. Abdul asks, does the router ID need to be routable? No, it doesn't. Like for example, all these things here, router ID of 255, 255.0.1, you're not going to find that in the routing table. Show IP route. Nowhere are you going to see that. That's not even a viable route. So definitely not. A lot of times, people will configure loopback interfaces on their routers. And because the default behavior of OSPF, when it first starts up and says, okay, I need to name myself, I need a router ID. Well, the first thing it normally looks at is, okay, is one statically configured with a router ID command? If the answer to that is no, then it'll say, okay, do I have any loopback interfaces? And if I do, I'll pick the highest IP address of my loopbacks and I'll name myself that. That'll be my router ID. And a lot of times people will include that loopback in their OSPF network statement, so that loopback address is a routable address. But it doesn't have to be. The router ID is just a distinctive name for the router. It's just a way so that on the tree, they can name each of the points on their tree. It does not have to be routable. Let's see here. Jamal, you asked, how can we identify the attached router and understand the OSPF topology? Well, if I'm interpreting your question correctly, what I would start with, like on this guy right here, if I was walking this topology and I knew nothing about it, I was given access to CSR2, but I had no topology diagram whatsoever, and I want to build a topology diagram. And let's say show CDP neighbor isn't working, right? Because some of these routers are not Cisco routers. All right, well, let's see here. Maybe I can do it this way. So first I'd do show IP OSPF neighbor. And notice the neighbor ID column shows you not the IP address, but the router ID of your neighbor. So you can say, okay, here's me right here, and I know I'm connected to two other guys. or gals, depending on who you are. So 0051.1 and 0051.2. I know I'm connected to that. Furthermore, I know that I show IP OSPF, I am 0051.22. Okay, now that you know that, and now that you know these guys, you can start digging into their LSAs, right? Now that we know that we're directly connected to them, I could say, okay, what did I learn from the guy on the top? Show IP OSPF database. And you can actually say advertising routers. So I'm not even going to focus on, I want to look at router LSAs or network LSAs. I want to look at all the LSAs I got from 0.0.51.1. And I can see, okay, I got a router LSA from him and I got a network LSA. Apparently he is a designated router. Now it does not necessarily mean that for this segment right here, he's the designated router. He could have been the designated router for somebody else, but now I can start drawing out my topology based on that. So Jamal, hopefully that answered your question sufficiently. Oscar, what is the number of routers recommended or best practice in a single area? I have read that somewhere around 40 or 45 routers is the maximum that you should put in an area. I think a lot of it also depends on how many links each of those routers have. Like if all your routers have basically just 2 or 3 links, you could probably go a little bit bigger than that. But if one router has got like 50 sub interfaces and 20 loopbacks, well, that means his router LSA is going to be monstrous, right? Because it's going to be really big. So you probably want to have fewer of those routers. But as a general guideline, I've read around 40 routers is the most you should have in any particular area. So Ranveer, you ask a good question. What are some scenarios where we see the forwarding address? That goes a little bit above and beyond the scope of what I want to talk about today. I can just lead you in a certain direction there. If I'm trying to think of a scenario that I've seen. There was some scenario where you had router 1, router 2, and they were both connected to an area. It's been a long time since I've seen this, so I'm trying to hopefully remember it. Let's say area 21. And there was like a switch here. They were both connected to it. And let's say this was the 55.55 network. And it's been a long time, but something about how if maybe this guy was doing the redistribution, so he was the ASBR, but in reality, he also knew that router 2 also had a route to that. I don't know, maybe these guys are doing something else like EIGRP or something. And so router 2 knows, oh, even though it's my job to advertise the 5555 network, I also know via EIGRP that router 2 has reachability to that exact same network. And guess what? He can actually have a better path than me. Router 2 can actually get there faster or better than I can. So in that case, even though ASBR is advertising it, ASBR1 could actually put as a forwarding address router 2's interface. Because it says, hey, I know that everybody knows about router 2. He's doing OSPF. I have an adjacency with him this way, which means everybody else knows about him too. And even though he's not advertising the 5555 network, I know that he can get there. And he can get there better than me. So that would be a case of where ASBR1, our one and only ASBR, and his forwarding address would not have 0000. Instead, he'd have whatever the IP address is of this interface. That's all I can tell you at this point. I'd have to do a little bit more research to get any more details. Good question, though, Ranveer. All right, so Humayun, what's your question here? You say, and well, I'll take 2 more questions after this because it's already 12:30. So you said, I may have lost it, but why won't the ABR can't tell about ASBR with network summary LSA? Because in type 3, it recates, okay. So basically, to summarize your question, what you were saying is, hey, since the ABR right here is already injecting type 3 summary LSAs into this area, advertising this route and this route and this route, why can't he use that exact same type of LSA to advertise reachability to this guy right here? Why does he have to use a type 4 to do that? Well, here's the reason why. Because remember, the type 3 summary LSA, what exactly is it advertising? It's advertising routes, right? It's advertising subnets, prefixes, and the subnet masks that go along with those prefixes. So for example, when CSR1 is advertising this right here into this area as a type 3, router 1, router 2, and CSR2, they have no idea that connected to that prefix is a router with 000.2 and a router with 000.3, right? Those are our router IDs. They don't know about that. All they know is that there's a prefix on the other side of CSR1 known as 3330. Well, when this guy here creates a type 5, and that gets over here, what's going to be in that type 5? That type 5 is going to have his name, right? It's going to have, he's going to say, hey, I'm advertising some, once again, it was like the 99 network up here. He's going to say, hey, I'm advertising the 99 route to you, and the advertising router is 0.0.0. I think it was 2 in this case. Well, a type 3 summary LSA, its job is not to advertise the router IDs of routers that are not in your area, right? As an ABR, so imagine that you and I are routers, okay? We're both in area 51 and there's some other area over here. So I've told you that I am your ABR. You already know that via my router LSA. It's not my responsibility to tell you what the router IDs are of these guys over here in this other area. You don't care about that. They're not part of your tree. You could care less what they are calling themselves. You don't even care how many routers are over here. All my job is, in a type 3 summary LSA, is to tell you what routes live over here. So I can't use a type 3 to say, oh, by the way, there's a distinct router over here in this area, and here's his name. You're going to need to know that. Well, you will need to know that, but I can't use a type 3 to do that. That's not the job of a type 3. A type 3 summary LSA is only used to take networks from here and advertise them into here. So that's why the type 3 can't do that. All right, let's take 2 more questions here. Okay, so I'm not exactly sure how to pronounce your name, MD Mejiner Rahman Mola. So you ask, what about LSA 6, 7, 8, and 9? Okay, so I'll just give you a real quick overview of those real fast. So an LSA type 6 is used for multicast routing. So if you ever learn about multicast, you learn that, you know, when a router gets a multicast packet, like let's say there's a video server out there and that video server is shoving into the network a whole bunch of multicast video going to 225.777. Okay, it hits a router. Well, that router needs to know now, of all my links, what links do I need to forward this multicast on? So it needs some sort of multicast routing protocol to answer that question. So most people typically use PIM, protocol independent multicast, like PIM sparse mode or PIM dense mode, to do that. OSPF actually has some mechanisms to do that as well. There's something called multicast OSPF or MOSPF. And the type 6 LSA is used to carry that multicast reachability information. So type 6 LSA has nothing to do with your unicast routing table. Doesn't have anything to do with that. So, and actually, I don't think Cisco routers even support multicast OSPF. I might be wrong on that, but I think I read that a long time ago. Type 7 LSA. The Type 7 LSA is used for a special kind of an area called a not-so-stubby area. So you might research that, or NSSA, not-so-stubby area. And in a not-so-stubby area, you've got an ASBR, a route that's doing redistribution. But when he redistributes static routes, RIP routes, BGP routes, instead of converting those into Type 5s, because they're going into this special kind of an area called a not-so-stubby area, he injects those in as Type 7s instead. So they're still called external LSAs, just like the Type 5 are externals, but Type 7 is called a not-so-stubby external LSA. The Type 8, I don't, let's see here. Where did I see something about the Type 8? Oh, yes, I think the Type 8, in the world of IPv4, the Type 8, and I don't know if the Type 9 is in there, but Type 8 is definitely called an opaque LSA. Once again, Cisco routers don't support this, but the idea was somebody once a long time ago had this idea, hey, we've got this tree here where everybody knows about everything. Wouldn't it be kind of cool if we could use the OSPF LSA to advertise non-OSPF stuff? What if I want to inject some information into this area and get it through this area that had nothing to do with OSPF at all? I just want to use OSPF as like a transport mechanism. So that is a Type 8. It's called an opaque LSA, where the opaque LSA, the body of it, is carrying non-OSPF stuff. I don't know if anybody has ever actually implemented that in anything, but that's the Type 8 and possibly the Type 9 as well. So, all right, I think at this point we have run out of time. It's been about an hour and almost 40 minutes. So thank you everyone so much for your questions. Thank you for watching the webinar today. I hope this webinar enlightened you and helped you learn a whole bunch of stuff about OSPF LSAs that you didn't learn before. And thank you all so much for attending.